Our project is called Machinic Geoscapes and it focuses on creating a primary structure that stays on site the longest using design tools that we develop in the studio for machine learning. As described by Stuart Brand's shearing layers, different layers in a building have different temporal qualities. Site stays for eternity, structure for 30 to 300 years, skin for 20, services for 7 to 15, space plan for 3 to 30, and the stuff that can move daily. We are interested in exploring how quarried stone can act as a structure and 3D printed stone can act as a skin for a building. We then explored qualities and limitations that stone has, like sourcing, its physical and chemical material characteristics, and its natural ability to promote non human growth like algae and moss. These are some of our initial experiments where we tried to create bioreceptive spatial qualities, stone textures, and poche and pocketed spaces. We created design tools using machine learning to place a primary structure on site. For this, we utilized Pix2Pix to teach the computer how to generate new structural layouts based on inputs with multiple layers of information, typically found in the design process, such as a hypothetical site and solar analysis, in junction with subjective inputs in the form of intuitive line-based sketches. We identified different characteristics in the structural layouts of ancient stone buildings that contribute to the structural stability, like stepping, symmetry, and poche. The initial data sets incorporating corresponding input and output generated layouts with different zones of density that indicated moments of structural and spatial redundancy while following the material logic. Based on these results, we developed a design criteria to help us guide the direction of the datasets by incorporating 4 zones: a dark zone for tech, Goldilocks zone for human habitation, a buffer zone for incorporating human and non-human together, and a wilderness zone for non-human organisms. For our computational logic 1, we ran a sun analysis that allowed us to visualize different degrees of solar gain throughout the site. The structural layout becomes a heterogeneous network of spaces that provide environmental conditions to suit human and non-human inhabitants. For our second computational logic, the gestural sketch becomes the driver for the location of an open space in the wild zone. The criteria for subdivision gains complexity by taking into consideration both sun analysis and the proximity to open space defined by the subjective input. Our three-dimensional translation of the dataset acquires a stepping condition that contributes to its structural stability and its surface articulation to promote the creation of new environments. Our third and most current computational logic utilizes the categories developed in the prior computational logics as well as the stepping condition. The buildable area first gets subdivided into irregular orthogonal interlocking regions, and the region with the largest area becomes the open space. Then the borders between these regions thicken to allow for wilderness to spread through the site. The edges are divided and selected on the basis of regions that need flexibility for future intervention and openness on site. By incorporating the developed stepping condition and the output depth map, we generate an informed three-dimensional primary structure. We then started experimenting with an infilling secondary structure that also added to the variation that we were trying to achieve. The three-dimensional logic was developed by taking the stepping for extruding the primary structure and infilling a secondary structure that is guided by the gestural sketch and the corresponding height. In order to train the machine, we started experimenting with inputs. We realized that a detailed and color-coded input required less training to produce more accurate results than an input that was poorly coordinated. We then tried various permutation and combinations of inputs by keeping one layer constant and the rest of the layers changing. After training using pix-to-pix model, the new depth map image serves as an index for extrusion values. After the extrusion, a complementary logic creates new infilling structures, stepping logics, and skins. We looked at different stone construction techniques throughout time to understand how to shape and assemble it while maintaining its structural capabilities, and used Puma Punku as a case study. Now, with the system in place, we started incorporating construction and assembly logic in stone parts on the basis of volume and divisions. We also started detailing out openings, hollow pocketed sections, and slide and floor connections. By keeping the primary structure constant and the skin replaceable, we provide for multiple plan alternatives for the same building. For skin, we decided to use 3D printed stone as it can very intricately carve out detailed textures that will enhance the natural bioreceptivity of stone and is also easily recyclable. We wanted to create a design tool that predicted weathering using rain analysis so that we could input the digitally printed stone where rain would create the most weathering according to our tool. This digitally printed stone has bioreceptive textures to enhance and sustain growth of non-human. Once the 3D printed stone is weathered heavily, it can be easily replaced. To predict weathering on stone, we analyze the erosion process that the rain causes. We build two models, the flow model of rainwater and the process of water transportation within the walls due to a capillary action. We then analyze different roof types and how they channelize rain. Thus, after applying the skin, we start cutting it out to create spaces for water collection. We then experimented with textures. We wanted to create areas which have indirect sunlight, some amount of water retention, and wind buffer. At this step, we analyze the area separately for rain, light, height, and the curvature to get the texture that can guide the rainwater into pocketed spaces and reduce the direct sunlight where non-human inhabitation can happen.